Final review problem number 2. We're going to look at some characteristics of a traveling wave. So here's a sinusoidal wave. It's actually a cosine function at this moment in time. It's traveling to the right. And in this picture of the wave, we're given some information. And we're going to determine some of these properties of the wave. So first of all, let's figure out the amplitude. Now remember, the amplitude of a wave is the distance from the equilibrium point to a peak, to the maximum height. So they give us 2 times the amplitude. From the bottom to the top is twice the amplitude. So this amplitude value is going to be half of this number. So 8.26 centimeters over 2, which is 4.13. And the next thing we're asked for is the wavelength. The wavelength is the distance from one point on the wave to the next identical point on the wave. That could be from a crest to a crest, or a trough to a trough, or any identical point to its next identical point. So maybe I'll draw the wavelength like this. That's a wavelength. This is also a wavelength. And if you look at this picture, they are giving you not a full wavelength, but a half of a wavelength. So we need to multiply that by 2. Now, period. They give you a number for frequency. I think everyone has a different number, so I'm not going to write it down. And the period is just 1 over the frequency. 1 divided by f. And the speed of the wave. All waves obey this equation. Speed is f times lambda, frequency times wavelength. So, to sum up the main points here, we are given a picture of a traveling wave. Now, if you wanted to really visualize a traveling wave, it would have to be animated or a 3D drawing, because this is just kind of one snapshot in time. The wave is really traveling this way, and if you look at just one point on the x-axis, the wave is oscillating up and down in simple harmonic motion. But from the snapshot, we can figure out the amplitude. That's from the equilibrium position to the maximum height. We can figure out the wavelength. That's between 2 successive points on the wave. And we can calculate period and wave speed.